Atoms are the fundamental building blocks of everything we see and touch, yet they are mostly empty space. This emptiness is hard to grasp. Imagine an atom the size of a football stadium. The nucleus, where almost all the atom's mass resides, would be like a tiny marble at the center of the field. The electrons would be like buzzing flies, too small to see, whizzing around the stadium's outer edges. Between the marble and the flies, nothing. Just vast emptiness. This means that if we could somehow remove all the empty space from atoms, everything around us would shrink dramatically. A human being might become as small as a grain of sand, yet retain its full weight. However, the story of the atom gets even stranger. Quantum mechanics, the theory governing the microscopic world, tells us that these tiny constituents of matter don't behave as we expect. They aren't like tiny balls on fixed paths. Instead, they exist as probability waves. Imagine these waves like clouds of possibilities, smeared across space. The denser the cloud, the higher the chance of finding the electron there. But before we observe it, the electron has no definite location. This is where our classical intuition breaks down. The electron doesn't move from one point to another like a ball. It exists as a blurry cloud of possibilities spread across the atom. Only when we try to measure its position does it snap into a definite state. This snapping is what physicists call wave function collapse. Before we observe it, the electron exists in a superposition of states, a mixture of all its possible locations. Our act of observation forces it to choose one specific location, collapsing the wave function. This doesn't mean our consciousness directly affects reality. It's more about the interaction needed to make a measurement. When we observe the electron, we are interacting with it, forcing it to transition from a wave-like state to a particle-like state. The emptiness of atoms and the bizarre world of quantum mechanics challenge our perception of reality. If matter is mostly empty space and if particles only materialize upon observation, what does it even mean for something to be real? These questions lie at the heart of modern physics. While we don't have all the answers, one thing is clear: the universe is far stranger and more wonderful than we could have ever imagined.